you got there? Well, really, first of all, that splits up, doesn't it? I can just say 3 over 2 to the n minus 2 over 3 to the n. Usually, that's what you want. If you've got a plus or minus between two fractions, I guess you might say, yeah, you want to split that into two things. That's, first of all, think about that. And so what about those individually, those series? What are they individually? Geometric, right? Write this as, what, 3 over, or 3 times 1/2 to the nth power. That's a geometric series. R equals 1/2. And it's, does that mean it's convergent or divergent? Well, geometric series, R between -1 and +1, that's convergent. Yeah. For a geometric series R between -1 and +1, you have convergent series. Well, here you got R's 1/2. That's between 1 and -1. So that one's convergent. What about the other one? Well, the other one is 2 times 1/3 to the n. We could write it. That's geometric with R equals 1/2. I mean 1/3. That's also convergent. So that one converges. That one. So we've got the difference of two convergent series. So this series converges. Now, the other good thing about geometric series, unlike the others, is we can actually say what this actually converges to, what this equals. What does this equal? Well, for convergent geometric series, for any convergent geometric series, the series actually equals, what does it equal? Well, it's A over 1 minus R, where A is the first term, R is the ratio. So we can actually say what this equals. This series equals that right there. First term divided by, what's the first term here? Well, that's where you got to pay attention to your little indices here. It starts at 0 here. Most of the time we start at 1, but every so often they'll change it to be 0, 1, 2, 3 for various reasons. But here, for whatever reason, they start at n equals 0. So the first term would be n equals 0, or look at it up here, whichever, 3 over 1, so it's 3. 3 is the first term. 1 minus 1/2 is the rest. This one, the first term would be 2 over 1 minus 1/3. And so that's 3 divided by 1/2 minus 2 divided by 2/3. What is that going to be? 6 minus 3? It's 3. Is that right? Did I do that right? 6 minus 3? I believe that's right. That's 3 times 2 over 1. That's 6. That's 2 times 3 over 2. So that's 3. Yeah, 6 minus 3. Okay? Now, compare that one to this one. 2 to the n plus 1 over 3 to the n minus 1. Why is this one different? This one's going in. Well, that one's different because can I split that one up like I split this one up? I can't split that one up like I split this one up. So that's one thing that's a key difference. So, yeah, this one isn't just an automatic geometric series 1. I have to use something else. What might be something else to use? That would be comparison, yeah. Matter of fact, here, if you think back on the comparison, it also does A sub n to B sub n. And we're going to run it, if I use just comparison test, well, let's just think about it. All right, let's think about comparison test. Comparison, I would say that's my A sub n, right? B sub n, what would B sub n be? Leading terms, yeah. 2 sub n, 2 to the n over 3 to the n. I'll say it right here in a second. Now, the reason comparison test might not be the way to go here is because, remember, on the comparison test, number one comparison is what? Well, you want, that's going to be 2/3. That's going to be a geometric series, isn't it? Which converges. And if I want a convergent series compared to this series, I would need this to be less, right? Well, is that going to be true? It's going to be hard to tell, isn't it? How are you going to tell that? Well, you could do some stuff. We could look at the derivatives, but it's not as clear cut as, well, I erased it already. That one previously where I had the bigger denominator over here, the smaller denominator over here, and I could tell which one. I can't really tell what's going on there. So that's one strike against the comparison test. So if you run into problems with that, then the next best thing would be limit comparison. The comparison test kind of falls through on that. So let's use the limit comparison test. See what happens there. All right, so what do we do for the limit comparison test? What's that? Yeah. We want to do the limit as n goes to infinity of a sub n over b sub n. That's right. So this would be the limit as n goes to infinity of 2 to the n plus 1 over 3 to the n minus 1 divided by 2 to the n over 3 to the n. Which, like we were saying, that's really the limit as n goes to infinity, 2 to the n plus 1 over 3 to the n minus 1 times 3 to the n over 2 to the n. Means the reciprocal times the reciprocal, right? We just do the reciprocal times the reciprocal of that. That's what we get there. Okay, well, still kind of up in the air, I guess you might say, because there's nothing that cancels out there. However, what can we do? I don't know that we've looked at one exactly like this. Yeah, probably go ahead and multiply this and this and this and this. Distribute that in. 2 to the n times 3 to the n. Isn't that 6 to the n? 6 to the n. Plus 3 to the n over 6 to the n minus 2 to the n. Yeah, this is an interesting one we haven't maybe considered before. Well, isn't this going to be the largest power here? The largest powered term or largest term? So let's divide by 6 to the n. One way we could go here. Divide top and bottom by 6 to the n. All right, so that would be the limit. N goes to infinity of 1 plus 3 over n divided by 6 over n. Isn't that 1 over 2 to the n? That would be 1, and that would be minus 1 over 3 to the n. Yeah, that kind of the same tricks we've done before, maybe not exactly like one we've done before. What does that all go to? Goes to 1. 1 plus 0 over 1 minus 0, that goes to 1. Does that tell us anything? Different tests, different results tell us something. Does that limit being 1 tell me anything? It does. As long as it's bigger than 0, it tells me something. What does it tell me? They both do the same, don't they? So this A sub n series so this B sub n series, if I look at B sub n as a series, that's the 2/3 to the n. Like we said, that's geometric, isn't it? R equals a 2/3 converges. So this series converges. So what must this series do? Converges also. And that's by the limit comparison test. Okay? So there is a lot, if you don't know what test to do, there is a lot of stuff you do have to consider, because sometimes one test may not work, what you think might, so you have to try there doing something else. All right. Okay, well, let me see what else I got here. What about this one? So I've got the series, and this one goes n equals 2 to infinity of n over ln of n. N equals 2 to infinity n over ln of n. First, number one thing is, why do you think they started here at 2? Yeah, if I start at n equals 1, the bottom is 0. So that's sometimes why they make the adjustments here. But anyway, what do you think? Here's one thing to think about. Which is bigger as you're going along? On the top or the bottom? Which of those is bigger as you go along? When n equals 1, n equals 2, n equals 3, which one's bigger? Top's going to be bigger, isn't it? Because the top is n, the bottom is ln of n. When you take the ln of a number, doesn't that make it a smaller number usually? Yeah, it does. Okay? So the top is bigger than the bottom. What does that make you think? If the top is bigger than the bottom, what does always have to be true about this? Doesn't that have to go to 0 for this to even have a chance of converging? Test for divergence. If this is not going to converge to 0, which it's not because this is bigger than the bottom, you might want to look at the test for divergence. Yeah, if this is not going to 0, as n goes to infinity, you want to use the test for divergence. And that's what was cluing me in there. I've got the top is bigger than the bottom, so that doesn't seem like that's going to 0. It seems like it's going to some other number. Let's check it out. What is the limit as n goes to infinity of a sub n? How do we do that? L'Hopital, yeah. That's infinity over infinity. So that's L'Hopital. Derivative, do the derivative of the top over derivative of the bottom. Well, 1 divided by 1 over n means 1 times, doesn't this mean 1 times, it's 1 times n over 1? What is that? That's infinity. As I suspected, yeah. The top is bigger than the bottom, so that's not going to be, it's infinity. Even though it looks harmless there. The limit of that a sub n is infinity. So, by test for divergence, that needs to be 0. So by the test for divergence, this thing diverges. Yeah, since that's not equal to 0, it has to be equal to 0 for this to have even a shot at convergence. I mean, if it equals 0, that doesn't mean it converges. It just means, well, we can use some other test, but the test for divergence says that's not 0, so this thing diverges. All right. So remember that test for whatever. Yeah, the test for divergence doesn't tell you if something converges. It does tell you if it diverges, though. But it only tells you it diverges. Yeah, because on this one, has everybody got that one?
Yeah.
You sure? Okay. All right, this one. Just to compare it to our test. On that one, what does the test for divergence tell you on that one? Doesn't tell you a thing, right? Because if I just look at the limit of my a sub n, as n goes to infinity, that is going to go to 0, isn't it? Because that's 1 over n squared, 1 over n, 1. That is 0. So just the test for divergence, just compare it to the last one there. That tells me nothing, okay? So the test for divergence tells me nothing. Just to make that clear, okay? If that limit is 0, you have to go to some other test. You can't just use the test for divergence on everything because, yeah, all these things are going to go to 0. That have a possibility of converging. But that doesn't tell me this converges. What else? What I would have to do is do something else. What else might I do on that? Well, now that one, that one is looking like what? What are you thinking? Another comparison? Maybe another comparison, okay? Let's try the comparison. B sub n for the comparison would be the n squared over n to the 4th, which is 1 over n squared. Yeah, that'd be a good comparison because the sum then of the b sub n's would be the sum of the 1 over n squareds, which would be, what would that be? That's, what do we got there? It's P series, yeah, P series. P equals 2, which tells me what? Convergent or divergent? P equals 2. That was one of our other tests. P series, P bigger than 1 is always convergent, yeah. If it's less than 1, it's divergent. Okay. All right, well, if we go with the straight comparison test, I think it'll work out because the straight comparison test, number 1, says I need to look at a sub n and b sub n, how those compare, and if it's convergent, I need a sub n's to be less than or equal to. Is that true? I think that's a pretty easy comparison, isn't it? if I put it in this form, because the top's the same, the bottom has n to the fourth plus n cubed over here, so it's bigger. This denominator is bigger than the denominator over here with the same numerator. That's less, isn't it? That's true. So if, well, really on the comparison test, that's it, isn't it? If B sub n is convergent by the comparison test, and the A sub n's are less than the B sub n's, there's not another parts. That's all I need to look at. Got convergence, got this, that's less than, so A sub n is convergent, right? Because these terms are bigger than these terms. This converges, that's smaller, this converges, right? Since, might say it something like this, since my B sub n converges, and each A sub n is less than that. And that's by comparison test. CT. All right. Got one more. Got all that? Most of it? All right, so this one, there might be other tests that would apply to this one, but since we have it done in this little review session here, we haven't talked about the integral test. So I wanted to do one with the integral test. Like I said, there might be, this one might work out with a comparison test or a limit comparison test. But let's just do an integral test just to have one example of that, because really on what we did with the integral test was kind of important, because with the integral test we proved our P-series test. So the integral test, we used it to prove the P-series. So it's an important test for various other reasons too. So let's use the integral test on this one. All right, so the integral test says, well, let's compare that to the integral. Instead of n's, we've got x's, x to the e to the minus x squared dx. And we're going to go 1 to infinity, right? Same parameters. This one's a good integral test, isn't it? Because you see how that sets up as an integral? U sub, yeah. It's a nice little U sub. U equals negative x squared, so du would be negative 2x dx, or du over minus 2x is dx. Yeah, it sets up nicely. Oh, and then of course the other thing is, this is an improper integral, so you do the limit, t-limit thing. Limit as t goes to infinity, 1 to t, and then our u sub, so that would be x e to the u, and du over minus 2x. So that'll cancel out very nicely. It's just a nice e to the u substitution one. So be minus a half, wouldn't it? E to the u is e to the u, antiderivative. but u being minus x squared, this derivative is e to the minus x squared. With me there? From 1 to t? All right, so that's the limit as t goes to infinity, negative 1/2 e to the minus t squared minus a half e to the minus 1. So what happens there as t goes to infinity? Well, this, of course, minus make a plus, so nothing happens to it. It's as t goes to infinity, it's just there's no t on that, so that just goes to 1/2 e to the minus 1. Well, what about this? As t goes to infinity, what do you got on that? Is that a pretty easy one? I think so, because doesn't this amount to 1 over t times 1 over e t squared, e to the t squared? If I write it in that form there, e to the minus t squared means 1 over e to the t squared. So as t goes to infinity, your power is going to infinity, and then you're raising e to the infinity. It's getting pretty big. 1 over that would go to 0, wouldn't it? This goes to 0. So it just winds up being 1/2 e to the minus 1. 0 plus that, so it's just 1/2 e to the minus 1. Well, what does that tell me? The integral there goes to 1/2 e to the minus 1. Does that tell me anything? Well, the way the integral test works, if the integral converges, what happens to the series? So does the series, okay? So the integral converges, so does the series.